Lesson 18. In this lesson, we're going to multiply and divide radicals. So number 1, the square root of 6 times the square root of 12. Now, neither one of these radicands contains a square factor. So we're going to use the rule for multiplication, which says when you multiply the square root of any number a times the square root of any number b, where a and b are both positive, so you're dealing with real numbers, this is equal to the square root of their product, a times b. So we're going to multiply 6 times 12. We're going to get the square root of 72. And then we go back to our list to see if there's anything in this list that will divide evenly into 72. And I want the biggest one, so that's going to be 36. So that's going to be the square root of 36 times 2, which is 6 times the square root of 2. The square root of 36 is 6. It can come outside. So the answer to number 1 is 6 times the square root of 2. Number 2. 2 times the square root of 72 times the square root of 24. Now, if I multiply 72 times 24, that's a really big number, 1,728. So this time, instead of multiplying first, I'm going to reduce first. 2, 72, we just saw that one, is 36 times 2. 24 has a perfect square of 4, then that's going to be 4 times 6. So if I reduce this, there's a 2 outside, and a 6 will come out. It will have to be multiplied by the 2. That will leave a square root of 2 inside that radical. And then in the second one, the square root of 4 is 2, and it will leave a 6 inside of that one. Now the rule says when you're multiplying radicals that have coefficients, that is numbers out front, you multiply out times out, that is the outside numbers times the outside numbers, the coefficients, and the inside times the inside, or the radicand times the radicand. So that's going to give me 24 square root of 12. But the square root of 12, I go back up here to my square list, and I see there's a 4 here. So 12 will divide evenly by 4, so I will rewrite this 24, and the 12 becomes a 4 times 3. I can take the square root of 4 outside. It will become a 2, which has to be multiplied times the coefficient 24. So my final answer for number 2 is going to be 48 times the square root of 3. Number 3, the square root of 5x times the square root of 3x becomes the square root of 15x squared. I look in my square list. There is no number in this list that will divide evenly into 15, but x squared can be written x times x. So x squared is a perfect square. And to take the root of a variable, you take the exponent and you divide it by the index. And since 2 goes into 2 evenly, this is going to be x times the square root of 15. Remember, the square root of x squared, assuming, of course, that we don't have any non-real numbers, x is going to have to be bigger than 0, is x times the square root of 15. Number 4, the square root of 3y squared times the square root of 15y. Now I can go ahead and take the square root of y squared. That's going to be y times the square root of 3 times the square root of 15y. And now I will multiply inside times inside, 45y. And inside of 45, I look at my square list, there's a 9 in there. So I'll write that y times the square root of 9 times 5y. And the perfect square 9 can come outside as a 3, so y times 3, square root of 5y, and we're probably going to want to rewrite that 3y, square root of 5y. Number 5, the fourth root of 8y to the 8th times the fourth root of 2y to the 5th. When you multiply a fourth root, it has to be times another fourth root. And I get 8 times 2 is 16. Y to the 8th times y to the 5th is y to the 13th, because when you multiply, you add your exponents. Now, this time I need to be looking at my fourths, and my fourths are over here, and I see that 16 is in my list. The fourth root of 16 is 2. If you raise 2 to the fourth, you get 16. That means the fourth root of 16 is 2. So that's going to come out as a 2. Now 4 won't go evenly into 13. So we can rewrite this y to the 13th as y to the 12 times y to the 1. That's a total of 13. And now 4 will go evenly into 12. So this is going to be 2y to the 3rd, because 4 goes into 12 3 times, fourth root of y. 2y to the 3rd, fourth root of y is the final answer for number 5. Number 6, we have 4 times the square root of 5 times, in parentheses, the square root of 6 plus the square root of 5. Now this is going to be the distributive property, and remember, when you multiply radicals, the inside numbers are multiplied and the outside numbers are multiplied. And the index of the radicals have to match. So everything's a square root here, so that's fine. So if I multiply 4 square root of 5 times 6, that's going to be 4 square root of 30 plus 4 square root of 25, because 5 times 5 gives me the 25. The 4 square root of 30 will not reduce. There's no perfect square in 30, but the square root of 25 is 5, so that's going to be 4 times 5. So 4 square root of 30 plus 20 is the final answer for number 6. Number 7, the square root of 10 plus 5 square root of 6 times 5 square root of 6 plus 7 square root of 10. Now this is the full rule. Remember, first, outside, inside, last. And also we do the inside with the inside and the outside with the outside. So I've got to multiply this square root of 10 times this 5 square root of 6. Well, there's an understood 1 out here, so that's going to be 5 square root of 60. And then the square root of 10 has to go to the outside, so plus 7 square root of 100, because 10 times 10 is 100, plus inside 25 square root of 36, and then the last 2 is going to be plus 35 square root of 60. Now I've got to reduce this, so let me write the whole thing down in a straight line here so you can see. 5 square root of 60 plus 7 square root of 100 plus 25 square root of 36 plus 35 square root of 60. Now I'll do the easy ones first. The square root of 100 is 10, so that's going to be 7 times 10. And the square root of 36 is 6, so that's going to be 25 times 6. Now I've got to find the square that's in 60, and I go up here and I look in my list. 4 will go into 60. It's the only one. 9 won't go. 16 won't go. 25, 36, 49, and then these are all too big. So it's going to be 5 square root of 4 times 15. And down here it's going to be 35 square root of 4 times 15. Now the square root of 4 comes out as a 2, so it's 5 times 2 square root of 15 plus 70, 7 times 10, plus 150, that's 25 times 6, plus 35, the 4 comes out as a times 2 square root of 15. Alright, I need to keep going here. 5 times 2 is 10 square root of 15 plus 220 plus 35 times 2 is 70 square root of 15. And you'll notice that these two radicals have the same index and the same radicands, and they don't have any variables, so I can add those together. 80 square roots of 15 plus 220 is my final answer for number 7. Number 8 has two parts. The first part is the square root of x plus 2 square roots of 5. All of that is squared. So let's do the first part of number 8 first, and then we'll do the second part. To square a binomial means to multiply it times itself. You do not square each term. If you do, you're going to leave out the O and the I of the FOIL rule. So now I've got to do first times first, the square root of x squared plus outer 2 square root of 5x, inner 2 is plus 2 square root of 5x, and then the last 2 is plus 4 square root of 25. Outside times outside, inside times inside. The square root of x squared is x. I have 2 of these and 2 more, so that's 4 square root of 5x. And then I've got 4 times the square root of 25 is 5. So my final answer is x plus 4 square root of 5x plus 20. And I can't add any of those together because they're not like terms. You'd have to have the same index, the same radicands, and the same variables. And we don't have that for these 3 terms, so we're finished. So the final answer of part 1 of number 8 is x plus 4 square root of 5x plus 20. Number 8, part 2. The square root of x minus the square root of 5 times the square root of x plus the square root of 5. These are conjugates, so what's going to happen is your outer and your inner are going to cancel out. But let's go ahead and do the full rule and you'll see. So the first 2 would give me the square root of x squared. The outer 2 would give me plus square root of 5x, because inside times inside. The inner 2 will give me minus square root of 5x. And the last 2 will give me minus square root of 25. The square root of x squared is x. Plus that minus that is going to be 0. Those are opposites. And then minus 5. So the second part for number 8, the final answer is x minus 5. Number 9, the fifth root of y squared times the cube root of y. Now we have a problem here because you can't multiply unless they have the same index. And one of these is a fifth root and the other one is a cube root. So we have to use our property that says the nth root of x to the m can be rewritten x to the m divided by n. So y to the 2/5, the roots are always on the bottom, times y to the 1/3. Then we have to use our other property that says that when you multiply like bases, you add your exponents. So we're just going to have to add 2/5 plus 1/3. Of course, you have a fraction key on your calculator, or you can get a common denominator. If I want to add 2/5 and 1/3, my least common denominator is going to be 15, because that's the smallest number that 3 and 5 will go into. Well, I'm going to have to multiply the top and bottom of this fraction by 3 and the top and bottom of this fraction by 5. So that's 6 over 15 and 5 over 15. So that's going to give me 11 over 15. Now let's see. They want us to put it in simplified radical form. So we got to go backwards now and say that this is the 15th root of y to the 11th. Remember, the index is the root, it's on the bottom, and the exponent is the number on top. So it's the 15th root of y to the 11th. Number 10, the cube root of b squared c to the 7th over the 6th root of b c to the 3rd. Now I'm going to have to go to fractions on this one as well, because the indexes on those radicals don't match. If they did, we could just reduce with what's on the inside. But I'm going to have to write this b to the 2 over 3 root times c to the 7 over 3, because 3 is the root. That's over b to the 1/6 and c to the 3/6. Now, because I have division, it's going to be b to the 2/3 minus 1/6 and c to the 7/3 minus, and I can put it as 3/6 or I can put it as 1/2. I'm going to leave it as 3/6. Now I have to get a common denominator to do 2/3 minus 1/6, or you can do it on your calculator, but they have to have a denominator of 6. So I'm going to have to multiply the first one top and bottom by 2. So that's going to be a 4/6 minus a 1/6, which is 3/6, which reduces to 1/2. So I have b to the 1/2. Now to do c, I have to get a common denominator. 7 over 3 minus 3 over 6. My least common denominator is 6. The bottom one is 5, but the top one, I have to do the top by 2 and the bottom by 2. That's 14 over 6 minus 3 over 6 is 11 over 6. So this is going to be c to the 11 over 6. But if you look, they want this to be in a radical, so I need a common denominator for these two. So 1/2 is 3 over 6. So I'm going to write this b to the 3 over 6 and c to the 11 over 6 so that they are the same radical. They're both the 6th root of b to the 3rd and c to the 11th. Now it does say that the radical has to be simplified. So 6 won't go into 3, but 6 will go into 11. So the last step I have to take is to write this c to the 11 as c to something 6 will go in, and then what's left over. So 6 will go into 6. It won't go into 11, it won't go into 10 or 9 or 8, but it'll go into 6, and 6 and 5 add up to 11. So the 6th root of c to the 6 is c. Then I have left the 6th root of b cubed c to the 5th. And that won't reduce anymore because that index 6 can't divide evenly into 3 or into 5. So the final answer for number 10 is c times the 6th root of b cubed c to the 5th. The square root of 2/3, number 12. Very similar to the last one in that I need to rationalize my denominator. So I'm going to multiply top and bottom by the same number, and this is going to give me the square root of 6 over 9. Now I can separate this square root of 6 over the square root of 9, so my answer is the square root of 6 over 3. Now be very careful, you can't divide that 3 into that 6 because 3 is a rational number, that is a number with no root, okay? And the square root of 6 is an irrational number that can't be reduced. Number 13. -7 over 3 square root of 2 minus 1. This is a little bit trickier, but once you learn the method, it's not that bad. Whenever you have a binomial, that's two terms, 3 square root of 2 is the first term, minus 1 is the second term, you must multiply by the conjugate. The conjugate is the exact same expression, but with the middle sign, or the sign between the two terms, has changed. Now I have to do the top and the bottom by the same thing. So I have to multiply my -7 times both of those, and I'm going to put my parentheses to remind you I've got to FOIL out my denominator. That's going to give me -21 square root of 2 minus 7, because I'm distributing this -7 times both. Then in the denominator, because I picked conjugates, the inner and the outer will add to 0. But let's go ahead and do all of them. 9 square root of 4, that's the first times the first. And then the outer 2 is going to be plus 3 square root of 2 times 1 is 3 square root of 2. Minus 1 times 3 square root of 2. And look, those are going to zero out. And then -1 times +1 is -1. So because these are opposites, 3 of those minus 3 of those is 0. So I end up with -21 square root of 2 minus 7 over 9 square root of 4. And what can I do to that square root of 4? Well, I can reduce that. That's 9 times 2 minus 1. So it ends up being -21 square root of 2 minus 7 over 18 minus 1. And the last step is -21. And the last step is -21 square root of 2 minus 7. All of this is over 17. So that's the final answer for number 13. Number 14, the cube root of 2b to the 10th over 25a. Now this means I need to not have a cube root in a denominator, and I've got a denominator there that's not rational. And so what I've got to do is I've got to find a cube that 25 will go into, and I've circled it over here. If you divide 25 into 125, it goes 5 times. So I need to multiply the top and bottom by another cube root, because you can only multiply a cube root times a cube root. I need to multiply this 25 times 5. And I only have a single a, but I need something that 3 will go into. So if I include a to the second, I'll have a to the third. So watch how this works. If I do the bottom, I have to do the top also. So I've selected to multiply the top and the bottom by 5a squared. That's going to give me 10b to the 10th a squared, because 5 times 2 gives me the 10, and then b to the 10th and a squared. But look at my denominator, 125 a to the third. Now I can separate these. The cube root of 10 b to the 10th a squared, and I could write those in alphabetical order, but it's okay like that, over the cube root of 125a cubed. Now the bottom is rational, so that's going to be 5a. The cube root of 125 is 5, and the cube root of a cubed is a to the 1. Now I have to look in my numerator, and I have to decide, are there any perfect cubes in 10? And look, here are my cubes, 8, 27, 64. So I'm not going to be able to do anything with that cube root of 10. However, b to the 10th can be written, so let me rewrite this numerator. The cube root of 10, b to the 9th, b to the 1, because I want something 3 will go into it evenly for the exponent, and then the a squared, there's nothing I can do about that. Now the cube root of 10 is going to have to stay inside. The 10, I have no factors that will go into 10. So like I said, the 10 stays inside. The b to the 9th can come outside though as b to the 3rd, because when you do powers, when you do exponents, you divide. 3 into 9 goes 3 times, but there's 1 left inside. The 10's still inside. There's also an a square and the b. Now I can't divide this outside a with this inside a, and I can't divide this 5 with this 10. So this is my final answer for number 14. b cubed times the cube root of 10a squared b, all of that divided by 5a. And that's a rational denominator. Look, rationalize the denominator, because there's no square root or cube root or any kind of root in our denominator, so we have rationalized it.